Okay, so what's a vector? A vector is quantities such as position that have both magnitude and direction. In our experiment, we did relative motion, and we are trying to prove that a car going 20 meters a second and a car going 15 meters a second is seen by the truck, like the trucker's point of view, as going 5 meters a second. So what we did is we have the vector of the car relative to the ground, which is 20 meters a second. Then we have the velocity of the truck relative to the ground is going 15 meters a second. So to figure out this problem, you have to do 20 meters a second minus 15 meters a second, and your resultant is going to be 5 meters a second. And that's all there is to it.
Alright, so for our experiment, we used remote control cars to prove relative motion. We started off, we got a monster truck here and a race car here. We used these two different cars because the race car is going to be a lot faster than the monster truck, which is going to be important for later. The first part of the experiment is we set the monster truck up here, and we set a motion detector on top of it, and we placed the race car right directly in front of the monster truck, and we had a pen on the back for the motion detector to read off of. We then had the race car just take off, and we measured how fast the race car was going relative to the truck, which is the same thing as relative to the ground because the truck wasn't moving. And then the second part of our experiment was we had the same setup, only this time the truck was following the race car, and because the race car was going faster than the monster truck, the car is gonna still move away from the truck, but it's not gonna be moving away as fast because the truck is moving this time. So the speed of the car relative to the truck is going to be a lot slower now because the truck is moving, so you got to subtract the truck's velocity from the car's velocity.
All right, you're good.
Go.
Okay, this is the actual data, the voice or the motion detector I recorded during the actual experiment. The first part of the experiment was when the truck was sitting still and the car was just taking off. So this is the velocity we got for the car relative to the ground, which was recorded from the truck because the truck, again, wasn't moving. And the time in seconds is on the left, and we took it over about a 1 second time period. And then here's the velocity. As you can see, it's just steadily increasing. And then over here, we have the velocity of the car relative to the truck when the truck was actually moving. So this was the second part of the experiment. The same thing, we still got the time over here on the sides, and then on the left side, and then the velocity on the right. But this time, as you can see, the velocity is still steadily increasing, but it's increasing at a much slower rate, and the final velocity is a lot smaller over here because, again, you subtracted the truck's velocity from the car's velocity, which is why this number is a lot smaller. Over here, we just drew a graph of the velocity over time for the two different cars, or for the car and the truck. The slope, the more steeper slope is going to be the velocity of the car over time, and the truck is going to be a lot slower when the truck was actually moving. So this line is represented by the velocity of the car relative to the ground when the truck wasn't moving, and this was the velocity of the car relative to the truck when the truck was moving, and that's why this is a lot slower.
Let's pull the two-seat out, baby. First verse, I'm armed till I'm on the island. My life's riding on the Autobahn.